Welcome to part two of our topic of compound interest. What we learned in part one was very simple compound interest, where we compounded it yearly. And the formula we came up with was a to the t is equal to a sub 0, which was our initial investment, times 1 plus our annual rate raised to the t power, which is the number of years. What happens if we want to compound this semi-annually, twice a year, or quarterly, which is 4 times a year, or monthly, 12 times a year? And that's when this gets a little more complicated. And so our formula is going to get just a little bit more complicated. And here it is. And then we'll explain what it means in a minute. The formula simply says that a sub t, our initial investment, is equal to our principal, or our initial investment, a sub 0, times 1 plus. But notice now there are some things that are different. We have 1 plus the rate, but it's divided by n, which is the number of times the interest is calculated each year, raised to the nt power. So let's see what all that means. Let's give an example. So let's say we have an initial investment of $500. So a sub 0 is equal to 500. And let's say our rate is equal to 4% or 0.04. Let's say we're going to compound this for 10 years, so t is equal to 10 years. But now let's say we want to compound this twice a year, semi-annually. That means our n would be equal to 2, which is 2 times per year, twice per year, twice per year. So let's do an example like this. So let's see how this works out. According to our formula, we have 500, our a sub 0, times 1 plus, and you notice that we have 0.04, which is our rate, but we're dividing it by 2, which is the number of times we're compounding a year. What that really is saying, since 0.04 divided by 2 is 0.02, what that's saying is we're doing 2% after 6 months, and then 2% again 6 months later. So essentially, you're going to have to divide your rate by the number of times you are compounding in a year. In this case, we're dividing it by 2. So the rate is 0.04 divided by 2, or 2% at the end of the first half of the year, and then 2% again the next half of the year. Now, we want to raise this to the number of years. In our case, we said it would be 10 years, but think about it. We're not compounding it just 10 times. You're compounding it twice a year for 10 years. Well, that's 2 times 10, or 20 times. And that is why you're multiplying this n times t. So once again, you have your rate, which is here. N is right there. You have t over here. And once again, you have n over here, because if it's being compounded twice a year for 10 years, that's 2 times 10, or 20. And then you just put this in a calculator, and you work it out. And if you did that, you would get a total of $747.97 at the end of 10 years. So you would have made $247.97 interest over the course of your 10 years if you compounded this twice a year for 10 years. Okay, so now we're going to do a problem, and we're going to have you do a problem at the same time. So our problem, we're going to have an initial investment of $1,000, an annual rate of 8%. We're going to compound this for 5 years, and we're going to do it quarterly, or 4 times a year. Here's what we want you to do. we want you to write this down right now. Pause this screencast and write down that the initial investment will be $1,500. It's right here. That your annual rate will be 12% or 0.12. That the number of years you're going to do this investment for is 10 years. And the number of times interest is calculated per year, which means the amount of time it's actually compounded, is going to be monthly, which is 12 times per year. So pause the screencast, write all this down, and when you're ready, press the play button. Okay, so now we're going to do our problem. And let's make a little bit more room here. So here's our formula. And let's see how this goes. We know that our initial investment is $1,000. That means our A sub 0 is equal to 1,000. So we could put A sub 0 here, just so we remember. Annual rate is 0.08, and that is our R value. The number of years is 5, and that is our T value. And the number of times it's calculated per year or compounded per year is quarterly. And that is our N. So we have our A sub 0, we have our rate, R, we have our T, and we have our N. Okay, so let's do the problem. So all we have to do is substitute into the original formula. And what we have here is our A sub T is equal to $1,000 times 1 plus the rate, which is 0.08, divided by N, which is our 4, because it's quarterly. We're compounding this 4 times a year, so our rate at each quarter will be 8% divided by 4, which turns out to be 2%. 2% after 3 months, 2% 3 more months later, 2% again, and then finally at the end of the year, 2% again. And how many times is this going to be compounded? Well, it's 5 years, but since it's 4 times a year, you have to multiply 4 times 5, because after 5 years, it'll actually be compounded 20 times. What I want you to do right now is pause this screencast, go to the problem that I gave you, and see if you can get to the point where I'm at, where you're simply substituting into the formula. And when you're ready, unpause this, and we'll continue. Okay, hopefully you're ready. Let's move this up. Now that we have our formula, let's see what we can do. One way of simplifying it, just a little bit, is 1,000 times 1 plus, now 0.08 divided by 4 is 0.02. 4 times 5 is 20. And you can make this even a little simpler, because on your calculator, you're going to want to write it like this. 1,000 and 1 plus 0.02 is really 1.02 to the 20th power. And if you do that calculation, you will get a total at the end. You will have $1,485.95. And that is the amount of money we'll have after 5 years compounded quarterly at 8% interest. Not bad for 5 years. We made $485.95. So what we need you to do now is go back to your problem, figure it out, and see what answer you get. And if you do it correctly, let's hope you do, and we'll bring it into class tomorrow, and we'll take a look at it. So once again, here's ours. Here's our final answer. Look at what we did. You figured out, and good luck. And we'll see you again.